Okay, thank you for doing such a great job building the slideshow that we'll be using for today. Um, I notice almost everyone contributed a slide, and I see most of you put a lot of effort into that, so thank you. I'd like to add a couple of key observations above and beyond what you've already added. You can imagine that, first of all, the College Board will ask you about specific biomes. I have seen all the questions that they've ever asked about biomes. And so pretty much the stuff that I add is things which I know the College Board would care about. The other thing to consider is, even if they're not asking you a question about a specific biome, any topic they're discussing happens in a biome. Biomes cover the whole planet. So if they're talking about pollution in a coral reef, it helps to know about coral reef biome. If they're talking about mining in the alpine environment, it helps to know about the alpine environment. A lot of times, knowledge of biomes is just embedded in other environmental issues. So now that we've been learning about basics of ecology and associated sciences like evolution or whatever, it's probably good to know about the Earth. I hope that you will add to your biomes cheat sheet that you made as biomes assignment number 3. First, you have to know these bands around the planet. They're color coded here: polar temperate, tropical in the north, and then tropical temperate polar in the south. These are roughly 30-degree bands, so 60 to 90, 30 to 60, 0 to 30, and south. They correspond to different patterns on land and in the ocean. So these bands are going to come up quite a bit for us, and you have to know the names and the latitudes. This is often in AP tests as embedded information. They'll say blah, 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 temperate biome. So you have to know that temperate is 30 to 60. And then you kind of have to know which biomes match up. Throughout the day, you may want to pause and come back to this map, which incorporates all the biomes. I asked you to make in your slide a map that showed just the tundra or just the desert, but here you have them all. And you can see that there are polar biomes like the tundra, temperate biomes like temperate deciduous forest, boreal forest. Then there are the chaparral, the deserts, and then there's the tropical stuff like tropical deserts, tropical forest, tropical savanna. Okay. And of course, these are all different because they have different degree of seasonality. You should write that down. The degree of seasonality. And this is one of the most fundamental things in science, but strangely, no science really requires that you know why there are seasons. It's just assumed that you learned it in another science class. So I'm going to try my best to give you a 2-minute explanation of why there are seasons, because the degree of seasonality affects ecosystems. So I'd like you to please look at my speaker view. I know it's small on your small screen, but here's me with the orange t-shirt and the ugly beard. When our planet spins around its axis, we call that a day. And when the planet makes a rotation around the sun, you might remember the songs from preschool, that's a year. So you get another birthday when you've made a trip around the sun. It's been 1 year. Now, the fascinating thing about our planet is that the axis of rotation, remember that's a day, here's another day, here's another day, here's another day. Okay, so the axis of rotation is at 23.5 degrees relative to vertical. Our planet doesn't spin like a top, it spins like a top that is falling over. And throughout the year, that angle is consistent. So for part of our trip around the sun, the northern hemisphere points kind of away from the sun. And then for part of our trip around the sun, the northern half is kind of leaning into the sun. It's not distance. Be careful, common misunderstanding. It's actually counterintuitive for our hemisphere. We're closer to the sun during winter. That's not a typo. I said that correctly. Our coldest season in the north is when we are closest to the sun. So it's not distance, it's how our hemisphere is oriented. In the winter, we are over here relative to the sun. So in the winter, the northern hemisphere spends a lot of time on the dark side and just a little bit on the sunny side. You can see that now on the screen here. You can see that most of that daily rotation is in the shade, with just a little bit of sunlight hitting the northern hemisphere. We call that winter because we don't receive very much sunlight. The days are shorter. We call this one summer because for most of our spin around the axis, for most of the day we're in the sun. So those are some long sunny days. And you know this from going to the beach. If you spend more time in the sun, you get hotter. So winter is cold not because of distance. Winter is cold because there's just not a lot of hours of sunlight. Summer is hot because there's a whole bunch of the day spent in the sun. Very little of the day is on the shady side. Of course, if you're in the southern hemisphere, that's opposite, right? During our summer, it's their winter. Most of that spinning for the south is in the shady part. Because of that angle, we get 12-hour day and night, 12-hour day and night, but we in the north get very short days, and we in the north get very long days. So this would be winter, spring, summer, fall. One trip around the sun is a year, one spin around the axis is a day, and some days get more sunlight than others. That's seasons. And again, if we had more time, I've got this bitchin' demo in my classroom, but I don't want to waste your time on this since I can't really show you all of this. Just take my word for it that different bands notice this effect more. So if you're at the equator, that's actually a 12-hour day, and this is a 12-hour day, and this is a 12-hour day. So in the equator, there are no seasons. But if you're in the Arctic Circle, you get 30 days of nonstop sunlight. That's a very long summer, followed in the opposite part of the year by 30 days of night. Like the vampire movie, 30 days in the dark. So less seasonality, increasing seasonality, most seasonality. You do have to know that the degree of seasonality increases as you travel toward the poles. It's more significant the further you are from the equator. So speaking of the poles, let's do this really quickly. Thanks to all the students who made slides about the tundra. I thought these were very well informed. They had excellent details. You can see a variety of maps that show you where the tundra is. Tundra is almost entirely around the Arctic Circle, a little bit actually around the South Pole. We'll explain why there's alpine regions that are separate from the tundra later. But after you've looked through all of these slides, I'd like you to note, in addition to what you already wrote, that these areas have extreme seasonality. So there's a really short period of super summer, and then there's an opposing total blackout winter, and they're extreme. So in the tundra, there will be 30 days of night with zero sunlight. Think about that. Nothing can live. Put any plant in the freezer for 30 days. Good luck trying to grow that plant. There is no life which can survive in the tundra unless it has extreme cold hardiness, hibernation, and dormancy. So like those mice and those foxes that live underneath the snow or whatever. But there's no productivity that's year-round. Every plant in the tundra will sprout, grow, flower, make its seed, distribute those seeds, and die in that short summer window. What that means is the entire landscape goes off all at once, like a fireworks show finale. Pow, 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 pow. So while there's a total die-off in the winter, there's a total explosion of productivity in the summer. And if you think about it, there's very few resident wildlife. So that's a giant resource. Some wacky duck got drunk or confused or hit in the head, and it just kept on flying. And that wacky duck landed in a place that looked like that on the bottom. And it's like, all these flowers are setting seed and there's no other birds. And so that duck put on a lot of weight, got all shiny. And when the cold started to set in, the duck was like, well, I guess I'll go have babies. And when it went back to the breeding season of other ducks, that duck had a lot of babies. And we now have a phenomenon called migration. I need you to write that down for the tundra. Because there's so much productivity all at once, life from all over the world comes to join that food party, both on land and in the water. Maybe you know about the gray whales that migrate past us a couple times a year. All right. Tundra, extreme seasonality. No plants year-round. Extreme hardiness, hibernation, dormancy for the few animals that can survive here. And of course, why not just show up when it's going off? Migration. I'd also like you to note that humans barely touch the tundra. This is the most intact biome on Earth. More than 99% is untouched by man. The only things that we are doing here are not by our direct participation, but a primary human impact here is, of course, we're cooking the planet, and so the tundra is melting. I'd like you to make a little note here, methane hydrate, and then we're going to come back to that in the future in the energy unit and in the climate unit. Just write methane hydrate into your notes. That's something we'll come back to. Oh, these are out of order. Okay, we're not going in the order that I thought. We're going to skip around. Tropical rainforest is, of course, in the tropics. I have no idea how these are organized this way. But tropical rainforest is kind of like it sounds, you know, tropical and rainy. What I'd like you to consider about tropical rainforest is that this is the most productive landscape on Earth, year-round productivity, because if you know anything about the tropics, it's always warm, it's always rainy, it's always sunny, every single day. Technically, if you're at the equator, 12 hours of sunlight and warmth every single day with rain in the middle every single day. Man, so you get such vibrant, rich life. Look at that picture of the Congo or this picture of the Amazon. These are extremely vibrant, highly productive ecosystems. Basically, with warmth and rain and sunlight every single day, plants are growing in the most ideal environment possible. So they're just limited by availability of nutrients and access to the sunlight. So plants will grow on top of each other. They come up with all these neat tricks to get their nutrients, like eating insects, like trapping animals, like having bark that's very conducive to making nests so that the birds will poop and then the poop will dissolve to feed the tree. There's parasitic trees. There's a bunch of fascinating diversity here. Now, in environments that are super productive and super consistent, write that down. Super productive, super consistent. In those types of environments, you also have a whole lot of specialization. You'll have to write that down too, meaning that species can break up into smaller and smaller niches, because if you do something super specialized, you can keep doing it tomorrow, you can keep doing it the next year. You can afford to take a really rare niche because that niche is probably always going to be there. So there are frogs that breed inside of a bromeliad because the bromeliads are always there. There are trees that live on top of trees that live over other trees. And that would sound like a pretty sketchy way to make a living, but since those things are always present in a consistent, productive environment, niches get subdivided into many, many specialized niches. In other words, extremely high diversity. One thing that I need to emphasize, and this one always shocks my students, is that the soils here are horrible. Horrible soils. As a matter of fact, there's like no nutrients left in the dirt. Any nutrient that ever hits the ground is used up by another tree. So surprisingly, tropical rainforest, even though it's lush and full of life, look at that, you're like, oh my God, that must be great soils, right? But no, there's no nutrients left in the ground because the plant is always ready to grow. And so if anything dies, warm, wet, sunny, it'll decompose right away, and those trees will use those nutrients right away. Nothing is left in the ground. These are the worst soils on earth, no exception. Super shocking. College board will ask you every time because they think they're sneaking up on you because they assume you have a crappy teacher. Remember that tropical rainforest have really horrible soils because there's just nothing left around. A lot of specialization, a lot of niches. I should point out that tropical rainforest is primarily vulnerable because it's so far. There's no one there to hear you scream. Tropical rainforest, because of its remoteness, is vulnerable. There's not very much intact, even though it's a scary place to be. There are jaguars and spiders and venomous snakes, but there's also gold back there, and there's expensive trees that you can sell to make fancy desks for rich folks. There's like beautiful, funny looking parrots that you can sell to weirdos. And so the surprising thing is that tropical rainforest is globally protected. It's not like it's unprotected. It's just who the heck is going to protect it? It's so far and it's so deep and it's so scary that if you can get back there, you can make money. So the surprising detail is that the majority of our lumber comes from different trees. Everybody thinks that tropical deforestation is about like Home Depot building trees. That is incorrect. The majority of deforestation is for mining because there's a lot of money back there to be made and nobody there to stop you from getting it however you can. You know, a little bit of logging, but that's only for rare hardwoods, not for construction material. It's, you know, little bits of wood, not like huge Home Depot's worth of wood. Most deforestation is also for ranching, like livestock, and rarely for farming. With crappy soils, you can't really farm in the tropics. We should say about 30% or so is still intact. Maybe a little bit more, but not much more. Oh man, it's such a bummer that these are out of order. Savannas are tropical grasslands. And that's unique because grasslands tend to have more seasonality than rainforest. There will be like hotter and colder, wetter and drier periods. If you look at these climatographs, you'll notice that this is some seasonality, you know, compared to tropical rainforest, which has very consistent temperature and rainfall. Savanna actually has some ups and downs. Dry period, wet period, dry period, wet period. This is important because with hot and cold, wet and dry periods, you tend to favor the growth of grasses. Now, these grasses come in like two big hits in the tropics. Tropical grassland has these like two big hits of grass. It's probably important to point out this is the tropics, so when grasses grow, it's not like the grasslands of the American prairie, but it's grassland in the tropics, like that grass is going to grow overhead. And so these are very productive ecosystems. It's a lot of grass twice a year. And because it's super productive and it's a relatively large biome, especially if you look at that map of the African savanna, this is one of the last places on the planet that still supports a lot of large animals, and that's probably worth noting. Elephant, lion, wildebeest, zebra, all that stuff that you might have seen on documentaries about safaris or whatever. As far as human impacts, humans don't really like it there. It's a pretty hard place to make a living. So it's largely undisturbed. I would say that humans dominate a very small amount, maybe 3/4 should be intact. Of course, with the giant exception that those big animals are interesting if you have like shoulder pain or something. I don't know. People get really into like grinding up their spleens or grinding up their testicles or grinding up their teeth or whatever. So poaching is a huge human impact in the savannas. Another impact might be farming and ranching. It's moderately decent soil, much better than tropical rainforest. So there are efforts to grow food in the savanna, but it's a pretty hostile environment still, not a ton of impact. Farming, ranching, if you can work out the irrigation, and poaching, because people will pay for pretty much all weird animals. Okay, I'm sorry that these are out of order. Now we move back to the top of the temperate region. I'm going to show you another map. You can see in this one that we're just below the polar areas. This is called the taiga, and I need you to add another term for this. Taiga is also known as boreal forest, B-O-R-E-A-L, boreal or boreal forest. Some people call this the conifer forest. Conifers, like you might see in the background of my speaker view, you know, like conifers, like pine trees and stuff, things with needles. Remember that this is south of the polar regions. And this is, again, extreme seasonality, but winter is not pure darkness. Because we're under the Arctic Circle, even in winter, you still get a little peak at sunlight. Just a little peak of sunlight every day. And that's enough for really tough trees to live. There's usually water all around, but it's very cold, so it's tough to keep your water in. That's why trees have these cool needles. And because there's so much water during that extended thaw, spring, and summer, these trees grow really, really fast. Fun physics, the light comes from the side because of that angle of the planet. So the trees, because they're getting light from the side, they compete vertically. So they tend to grow really, really straight and tall and fast. That makes their wood soft. You might know that conifers are softwood, and that conifer, the softwood, is extremely valuable to humans. In those purple areas that you see here, that's how we stock the Home Depot. The majority of our planet's lumber comes from the taiga, or boreal or conifer forest. As you can see in the image at the bottom of this screen, all those trees are perfectly straight. They're right next to each other. You knock one over and then there's another one behind it. And you knock that over and there's another one behind it. And you just go and you just strip all the plants, all the green off. And now you got a nice round straight stick, and you can stack those on the lumber truck and you can drive them over to the mill and get a whole bunch of planks to stock your Home Depot. So taiga, boreal forest, conifer forest, this is lumber. This is softwoods. This is how we load up at Home Depot. That logging means that humans have impacted 20, 30, 40% of all boreal forest. It's not a nice place to live. Think of Siberia, like northern Canada. It's pretty rugged, hard living. But, you know, it's worth getting out there for the trees. Let me see here. If you can go to my screen here, this is what fills our Home Depots. This is what fills the rest of the United States Home Depot. This is what fills European Home Depots. This is what fills the Middle East Home Depots. This is what fills Russia and Asia's Home Depots. In other words, these are the trees that we cut down for wood. This is the most deforestation, not the tropics. Man, it is really tripping me out that these are out of order, and it's not your fault. I just put them in the wrong order. Okay, so we did tundra, then we did tropical rainforest, then we did the savannas, then we went back up to taiga or boreal, and now I want to get back a little bit further south to temperate forest. You know, temperate zones like you see in purple here or in green here. These are places that have like 4 distinct seasons. If you know about these parts of Europe or these parts of the United States, we have seasonality. It's not the tropics with no seasonality. And it's not the poles with like extreme seasonality. It's like kind of in the middle. It's not polar, it's not tropical, it's temperate, you know, clear cut 4 seasons. Temperate regions have clear cut 4 seasons. Write that down. I don't know how far we want to get into this, but with those 4 seasons, the math works out that a tree can grow really well for 3 if it can just grit its teeth and chill for that 1 winter season. So because so many days it can grow, it actually makes sense for trees to be deciduous. Vocab term, that's when the leaves fall off. This is often called deciduous forest or temperate deciduous forest. Deciduous means that the leaves fall off. These tend to be hardwoods. They compete sideways, so the wood needs really tight grain to support all the water weight out on the edges. And plants have this one down season. You should know that this is hardwoods. You should know that they are deciduous. You might have noticed also that these are the places where like all the humans are. I don't know if it's obvious from this map, but if you look at the places that are listed here, like this is like where all the people are. So hint, Christopher Columbus had it pretty easy. The first Europeans to come to the United States got pretty lucky. As hard as it was to be a pioneer and a pilgrim, at least they shared the same biome, right? And so the trees that grew here grow here, and the farm crops that grow here work here. So if you know anything about colonial history, you can probably imagine that when humanity was really charging across the planet to develop modern civilizations, they just ate through this biome like termites in my house. That was a really stupid one, sorry. But a lot of humans, a lot of humans, a lot of humans. And so this biome is practically gone. Humans dominate about 80-90% of this biome. There's very few little tiny fragments of intact temperate deciduous forest. Practically none. Yeah, just because of the history of colonialization. That's just kind of where, people are nowadays. If you move a little bit toward the center of the continents, so you can see that we were on the coast of the temperate regions, now we're in the middle of the temperate regions. P.S. This is where I'm from. Middle, this is where I'm from. So in the middle of the temperate zones, you get temperate grassland. I wish we had more time for this, but just scribble some quick things in your notes. There are 4 distinct seasons. Each of them has very different temperatures. You can see that on the climatograph, and you can also see that in temperate grasslands, here we go. Temperate grasslands, there is a little bit of rain in each. So there's like a hot, wet season and a cold, wet season and a warm, wet season and a windy, wet season. What that means is that the year is divided into 4 separate grass diversities. There's the summer grasses, the winter grasses, the spring grasses, and the fall grasses. And the way that grasses grow is the seed will sprout, it grows up, it makes its seeds, and then it falls over and dies. And then something else will grow, make its seed, fall over and die. And then something else will grow, make its seed, fall over and die. And so what you get is all these layers of decomposing grass, 4 layers a year. And you don't need to understand why that happens, but you do need to understand that grassland makes the world's best soil. Because grasses grow fast, they take a lot of stuff from the atmosphere and they make it into biomass. And so this is the part of the planet that has the best soils. America sure has a lot of grassland, which kind of explains why we dominate. We have a lot of farmland, right? Like if you're Mexico, good luck trying to be a global superpower. You can't really grow that much food. I mean, there are parts of Mexico where you can grow some stuff, but not like Kansas. You know, ditto a lot of other continents, you can imagine kind of hard to get your food if you don't have a lot of grassland compared to, you know, Middle East, Europe, Asia, North America, huge grasslands, huge food availability. Grassland equals food because world's best soil, because grass dies and composts the ground. The big connection to remember here is how tremendously good the soils are and why that's important for food production. It's really messing with me that these are organized funny. I don't know how I mixed up the slides, by the way. I have no idea what's happened. Maybe I got to blame a student. Maybe it was somebody else's fault. Anyway, we should talk about the alpine environment. Alpine environment is kind of like the polar environment, but there's sunlight. So, you know, extremely high elevation, so extremely cold, but there's sunlight. So this is pretty unique ecologically. It doesn't have the extreme seasonality, but it's still really crazy cold. And that's probably all we got to say about the alpine, I guess. These climates are disappearing quickly because the planet is warming, so all of the tops of the islands are shifting upward, right? Because as the planet warms up, the middle temperatures are climbing up in elevation. So it's probably worth noting that these are shrinking. They're like the polar regions, but for different reasons. But I'm going to rush. What I really want to talk about is the chaparral. That's where you live. In this picture, it's kind of tough to see. In this picture, it's really clear that right there at 40 degrees north and 40 degrees south on the western coast of each landmass, there's this really unique biome called chaparral. And I don't know, I probably don't have to tell you much about the weather because I think you live here. You should probably know that this is also known as Mediterranean, also known as temperate shrub land. Chaparral means like shorty vegetation, like midget vegetation or like stubby vegetation. Because if you go outside and you look at our vegetation, all those trees are like, and they're like suffering because it's so brutal here. This is where you live, so you probably know this. We have extremely long, dry summers and extremely wet but very rare storms. What you might find surprising is that everywhere else on the planet, it rains when it's hot, just not here. Like, if you bring cactus from the desert and you plant it in Santa Barbara, it will die. Because in the desert, it rains every single day. A little tiny bit, but it rains every single day. It's a little bit of rain, but it rains daily. Here, we can go 9-10 months without rain. That's brutal. There's like no other biome on Earth that has such a long, extended dry season. That's extremely notable. So here, there's almost no soil because decomposers can't survive and vegetation can't spare their biomass. Most chaparral is stunted and wilted. It barely grows, a teeny little bit. Like in that couple of weeks of rain, it'll be like, oh, here we go. And it'll make some flowers. And then it goes, and it goes back to suffering for like 9 or 10 months. Our vegetation is like stunted and dense and like waxy because it's trying to avoid evaporation, and it's kind of dusty and gray because like dust sticks to that wax. It's trippy. We live in a really weird place. We have really high wood density. We have really active seed dispersal. We have extended latency. Most of our vegetation just freezes and stalls without any growth for about 10 months a year, and then puts on a little bit of growth and then goes back to hating life. Very unique biome. Of course, it also has its beauty. You probably know that it's really comfortable. You can wear shorts and flip-flops every day. It's a little bit after 10 p.m. in the middle of February. I'm wearing a t-shirt, I'm wearing shorts, and I'm currently barefoot. Well after dark in the middle of February, and I pay a lot of money to live here because it's really nice. There's not a lot of Mediterranean biome on Earth, and humans love it. So this is probably the rarest of the major biomes. There was a very small land area to begin with. You can see that in this picture. Very small land area to begin with, and humans have developed almost all of it. That's why we make such a big stink about the Gaviota Coast, or about the Douglas Family Preserve, or about Point Conception, because these are some of the last examples of this biome anywhere on Earth. Every one of those chaparral zones in purple on this screen, every one of them is full of wealthy people fighting for their own little slice of that land. True of all 5 continents that have Mediterranean. It's where everybody wants to be. So it's probably the most endangered biome on Earth. Lucky you that you get to live here, and lucky me too. This might be the last one. Gosh, this is so weird that everything's all out of order. But I would like to talk about the desert. Now, what really defines the desert, and please write this down, the desert is dry, but technically more annual rainfall than Santa Barbara. Of all the deserts on Earth, there's only a couple of square miles that get less annual rain than we do. Almost all of those get more annual rain than Santa Barbara. It's true that it's dry, but what's a really big whoop about the desert is the extreme daily temperature change. Because deserts tend to be in the middle of the landmass, in the tropics, or near the tropics, these areas get little bits of rainfall, but they get tremendous variations in temperature. I've been in a desert where it was about 12 degrees when I woke up, like all the water bottles were frozen solid, and by noon it got to like 106, and then that night it froze again by about 1 in the morning. So in a 19-hour time period, the temperature went up 80 degrees and then back down. Maybe more, 90 degrees up and then back down. That is tremendous. This is extremely hostile to life. So hostile to life that almost everything in the desert is nocturnal. Obviously, there's adaptations to water storage. So like cactus stores, and there's like weird ants that store water, and there's like weird birds that have all these neat tricks to store water. But I should probably point out that most of the desert is not the sand dunes pictured here and here and here. As a matter of fact, most of the world's desert is vegetated, like what you see here. And it can only be vegetated because desert has this special soil. It's not just plain sand. This is what everyone thinks of when they think of desert, but sand dunes make up like 3 to 4% of the world's desert. Almost all the world's desert is not sand dune. Because when sand gets rained on and then the water evaporates, and then it gets rained on and the water evaporates, and then it gets rained on and the water evaporates, something really interesting happens. When you wet soil and then the water evaporates, it leaves little salt crystals. Maybe you've seen that in like an old glass that will start to get like a white film if you let the water evaporate too much. Here's a jar that I use to store scraps of water in my workshop, and I always forget about it, so the water just evaporates. And you can see that's like, I don't know, every 3 weeks I let that much water evaporate in this thing, right? Now imagine that buildup of crystalline matrix in sand for like thousands of years. What's interesting about the desert is this weird spongy soil, and I have to warn you, the College Board has repeatedly asked about the fancy desert soils. There's a bunch of words. So spongy soil, cryptogamic, I think, or I don't know. Maybe we can remember these names at some other time. You could ask me in class and I'll try to find them for you so that I can be more helpful. But the magic of the desert is this weird, crusty soil that's like a dried out sponge. You ever seen those like green sponges that old ladies use to like arrange flowers? It's like weird. You can like press it with your fingers and it leaves like fingerprints and it turns to powder, but you can like stick flowers in it and then they stand up inside of a vase. Flower arranging classes for the old ladies. Go to your grandma's closet. You'll know what I'm talking about. That dry sponge texture, that is the soils of the desert. Special, unique crust. And those tend to hold water. They tend to allow plants to root. And because of this special soil, that's why most of the world's desert is vegetated. It is not sand dune. Yeah. It's been a really long video already, and all I've talked about is the terrestrial biomes, but I think we got them all, right? We got deserts, we got savanna, we got rainforest, we got grassland, we got chaparral, we got deciduous forest, we got the boreal taiga, and we got the tundra. That's the big stuff. I think I'm going to call it good for the terrestrial stuff, and I'll make a separate video, probably tomorrow, for the aquatic biomes. I hope you got some good stuff out of this. I will see you back in class.